Assalamualaikum warahmatullahi wabarakatuh and a very good morning to my panel, Encik Faizal bin Zulkifli and Dr. Ida Shafiza binti Maisa. Thank you for spending your time to watch my Bachelor Degree Project presentation today. Next, I would like to thank my supervisor, IR Muhammad Afif bin Kasno, for his effort and support in order to make sure my project is done. First of all, let me introduce myself. My name is Norain Atika binti Muhammad Noor and I am from 3BEET. My project title is Development of Landslide Early Warning System using Arduino and Blynk. In this presentation, I will explain the introduction, problem statement, objective, project scope, literature review, methodology, and preliminary results. I will also show you guys my project demo. For the introduction, the development of landslide early warning system using Arduino and Blynk is focusing on monitoring using sensors based on IoT and can be monitored via Blynk application in the smartphone. The problem statement for this project is, as we know, landslides are one of the most difficult natural disasters to predict. And then, the minor of landslide happen based on some hint like warning sign such as crack on structure and also the concentrated amount of water flowing over the slopes. The objective of this project is to study the fundamental and system which related to landslide early warning. Next, to analyze the performance developed system during real outdoor situation, and lastly, to develop the IoT landslide early warning system based on Arduino and Blynk. The project scope is to focus the uses of IoT by using Blynk interface. Arduino is an open source that can be programmed using Arduino IDE software and that being uploaded into the Arduino Uno and monitored using Blynk. Next, to focus only on soil moisture sensor, ultrasonic sensor, and vibration sensor that can be monitored from far using Blynk's app. Next, in the chapter 2, I will explain about the literature review. From this chapter, I have made some comparison from the previous project. The first one is integrated earthquake and landslide monitoring over wireless sensor network. It can be concluded that from this project, it is using WSN to monitor the earthquake and landslide. The advantages is it has multiple monitoring station, and the disadvantages for this project is it is a high cost because they are using WSN. Usability. It can be concluded that these projects are using IoT to control and monitor the domestic usability. The advantages of this project is are using Blynk because it has a graphical interface that is interesting and easy to use, while the disadvantages of this project is it needs a good connection of internet. The third project is IoT-based landslide detection and prevention system. Okay, from this project, it can be concluded that they are using IoT to monitor the forecasting and warning of landslide. The advantages of this project is it helps saving numbers of lives. It also helps updating the information on the internet, and lastly, help to notify the residents about the upcoming disaster. While the disadvantages is delay efficiency and needs good internet connection. The last one is landslide early warning system based on Arduino with soil movement and humidity sensor. It can be concluded that these projects are using GPS to monitor the landslide with GeoCube system. The advantages of this project is it has the precious sensor data and good warning alert level because they are using LED as the indicator. While the disadvantages of this project is it needs a good connection of internet. In the chapter 3, I will explain about the methodology. In this methodology, I have separated the flowchart into two parts, which is part A and a part B. In the part A, I have started doing the design by using AutoCAD. I am designing the slope model for this project and get the result, which is the design of slope model. Okay, the next part is B, which is I start doing the literature review and make some comparison from the previous project, and I also do the sensor testing and Arduino Uno. So the coding must be coded into the Arduino IDE. So I have testing the sensor and get the results. Here is the slope model for my project, and the materials for this slope model is use acrylic sheet. This is the circuit design for my project. I have separated the circuit into two, and I am using two Arduino Uno. Okay, the first Arduino is for the sensor and the second Arduino is for the LCD and buzzer. Next, I will explain to you guys the preliminary results. Okay, from this table, it shows the data taken based on percentage of soil moisture and when the vibration sensor is 1. For the first condition, less than 50%, the condition is safe and the buzzer will turn off. While when the percentage is more than 50% and less than 70%, the condition is alert and the buzzer will turn on with delay. Last one is more than 70%, less than 100%, the condition is danger and the buzzer will turn on without delay. The second situation is data taken for the distance of ultrasonic when the vibration sensor is 0. There are two conditions for this situation, which is less than 5 cm and more than 6 cm. Okay, now I will show you guys the project demo. In this project, I have used two Arduino. Okay, the first Arduino is for the sensor and the second Arduino is for LCD and Wi-Fi module. Okay, for this Arduino, I have used three sensors, which is the first one is ultrasonic sensor that is used to detect the distance of the slope. Second one is the vibration sensor that detect the movement inside the soil, and lastly is capacitive soil moisture sensor. This is used to detect the amount of water flow inside the soil. In this project, I have decided to program a coding with two situations. Okay, for the situation 1 is the percentage of soil moisture sensor when the vibration sensor is 1, and another situation is when the distance of ultrasonic when the vibration sensor is 0. There are three conditions that needs to be fulfilled, which is for the first one, when the percentage is less than 50%. As you can see at the serial monitor, the percentage is less than 50%. So when I give a movement to the vibration sensor, it will display safe. At the LCD, it displays the status of safe. For the second condition is when the soil moisture is more than 50% and less than 70%. So here, I will put the soil moisture sensor inside the water. As you can see here at serial monitor, the percentage of soil moisture is increased. So I will give the vibration sensor 1 and it will display alert. Okay, so the status at LCD will also display alert. Okay, the third condition is when the percentage of moisture sensor is more than 70% and less than 100%, it will detect danger. So I will add more water inside the soil moisture. As you can see here, the percentage of soil moisture is increased. It's more than 70%. So when we give the vibration sensor 1, it will detect danger. And the LCD will display danger. And also the buzzer will on. Okay, here is the second situation. The sensor involved is ultrasonic sensor. For this situation, there are two conditions, which is when the distance is less than 5 centimeter, the LCD will display danger, and when the distance is more than 6 centimeter, it will display alert or safe. It depends on the soil moisture sensor. I will put my hands in front of the ultrasonic sensor, but less than 5 centimeter, which is here, and you can hear that the buzzer is sounded. So it means that when it's less than 5 centimeter, the ultrasonic will detect and the buzzer will on, and the LCD will display danger. Okay, for the second condition is when the ultrasonic sensor distance is more than 6 centimeter. Okay, here there nothing happen, as the ultrasonic sensor only will detect the object less than 5 centimeter. Before I end my presentation, I would like to make some conclusion. It can be concluded that from this project, users will be notified the current situation of the landslide from the Blynk application in the smartphone, so that the user can monitor and prevent the landslide from occur. And it also can save life and prevent from any property damage. That's all from me. Thank you.